In this video, we're going to use SetBackroundColor to visually aid the analysis process by coloring all calls along the call graph to a specific location. Let's say, for example, you have identified a piece of code. Let's say we've identified this code segment here, and now we want to know how can we reach this code segment. What you can do is you can call up the function call graph, and here we have the surrounding function that this statement is in. If we scroll up here, it's here, and then we can expand the incoming edges up here, and then we see all callers to this function up to the entry point. Now the problem is, if you now want to analyze the entry function to see how these functions here get called, you have a slight problem, because when you click this here, you will lose this function graph. What you can do is you can deactivate the incoming navigation, so you still have the function graph. However, you now have to manually look where these calls are. For example, this is AB at the end. Okay, it's none of the calls that we are interested in. Now let's look at the next call. This is this call right here. And what we're now going to do is write a plugin that will automatically set the color of these calls. So all you have to do to analyze it, go to the entry point, scroll down, and every call along this call graph will be colored. And also for the subsequent functions inside of the called functions. So let's get started. So first, for this to work, we will use the current address, which is the current address that the cursor is at. So the intention for the script is I have a specific code, this here, that I want to analyze, and then I execute the script, and it will then color all the calls that will eventually end up at this address. So next, we want to get the function that is surrounding this address. So we call the get function containing of current address. And then we get this function. If you look at the call graph, this is exactly this function here. And then we get the entry point of this function. So now we have the address, and from there we get the references to. So we copy this, and here we get a list of references. And what we then do is we iterate through them. For example, get the first reference, and then we get the from address. This part here. Then we also need to filter on the type. So we call get reference type. And so we see it's an unconditional call, and we can actually filter for is call, because there is other types of calls. For example, there is a computed call, and there is a computed jump, conditional call, conditional computed call, and we want all the calls. It's important, because if we don't do this, we also get data references, which could screw up our results. So this is the first part that we need. And the second part is we need SetBackroundColor. And this actually accepts the address and a color, a Java, and then for example, red. So now I've set the current location background color to red. Let's clear this. Let's see again. So this is how you set the color. And we will traverse our function graph with the above outlined functions, and then set the colors on the function calls. So let's put that all together. So here are the imports that we need. We need to have addresses, an address set, and color. And what I'm going to do is I start out with a bunch of addresses, which is an address set, because the SetBackroundColor also accepts a set of addresses instead of a single address. So we will simply collect all the addresses that we want to color and then issue one coloring command at the end. So we will do something like this, and then we define a function that we will then call recursively. Call it collectCalls. It will get the addresses from down here to which it will add the addresses that need to be colored. Then we use the get function containing to get the function containing this address. Then we get the entry point. Next we get the references to our entry point. And then for every reference in our reference list, we get the reference type and check whether it's a call. And then we add the from address to our little recursive crawl script here. And we also add this address to our set that will be colored. In fact, we could also add this call up here. However, then also the address from which you start the script will be colored. It's sort of a personal preference, but let's just do it like this. Let's do one more check. I don't know whether this needs to be done. If there is no function, we simply will return. And then let's see whether we can print the name. So for beat debugging, we will print out the name. So this looks good to me, or it's just missing the collect calls call. Now we can run our script. Let's see if that worked. Yeah, it seemed that it has traversed quite an amount of functions. And if we go to the entry point, we see that these here are colored. And if we look into our call graph, we will also see, hopefully, that this is the 0C, this is this one here. The 5.3 is this one here. The CD, okay, the CD isn't colored, so that's why I didn't find it in the call graph. Our point. So as you can see, the script works as intended. We can now analyze our code, and every time we see a marked function, we know that it will eventually lead down to the code that we previously executed the script on.